Right, hello and welcome to Decision Maps. I've got a few things to say organisationally. The first one is that next week we'll switch with Philip again. So next week is week 9, and you will have 1 hour of Philip here, and then 2 hours with me in the afternoon, late afternoon. Okay? That's thing number 1. Thing number 2, today we have Rachel sitting somewhere there in the back, who is just observing, so don't mind her. She's not observing, well, she is observing everyone as well, but it's not like she's recording everyone what they're doing and then sending it all the way to the team and things like that. She's just, it's part of, at MMU we have this peer observation scheme where academics observe other academics when they're teaching, so that they can this side of the teaching life. So this is part of this scheme, so don't worry too much about that. Is there anything else that I wanted to say? Oh, right, yes. What I wanted to say is that I've run out of the books that I've brought. So if you still haven't got the linear programming book, which some people have, then either come by my office or ask in the labs on Wednesday, Thursday, Friday. Right, this. So this was the homework, wasn't it? We had a linear program with the constraints of physique, personality, culture, self-image, reflection, and relationship. Oh no, this wasn't the homework. This is the leftover from some previous lesson. The homework was, in fact, this. Does that look more familiar? So let's go through. I hope you've at least started attempted to start. No, well, started solving this, and it's not at all different to what we were doing last week. So what you need is look at all the constraints when you're doing the simplex method, and each of the constraints gets its own slack variable, which I've called S1 and S2 over here. And then each of the inequalities with the slack variable is translated into an equation. And also with the top equality, I put the Z on the one side and all the decision variables on the same side as well. And then I've got 0 on the right-hand side, and I've got these. So you don't need to copy it because I'll put it in Moodle. And if you haven't done it, then there's no point copying it now. But you were supposed to have done it at home. Now, what we were doing last week was we pick a pivot element, okay? And the pivot element we identify, we look at the coefficients in this objective equation of decision variables, and wherever we see a negative one, and in fact, the rule that I didn't tell you last week, but there is a rule called Danzig's rule, which is not an entirely you don't necessarily have to follow it, but it's a good idea to follow it for the moment, please. Is that you pick the one that is the largest in absolute value, okay? So the most negative, if you like, and the most negative one is -6. So you're looking for a pivot element, either this 3x3 or this 3x3. So the pivot element tells you which of the 2 basic variables, S1 or S2, is going to lead to basic in this case, because 30 divided by 3 is 10, and 40 divided by 3 is 13 and a third. You pick the smaller one. So this is what we were doing last week, even though I didn't say it quite like that. But we'll see this again later today. So don't worry. If you don't understand at the moment, you'll understand in 10 minutes. Okay. So this is supposed to be the pivot element, which means that x3 is now in the basis, which means that it only appears in the first equation and not in any other equation, and it also has the coefficient of 1, which is not written there. Okay, this is the pivot element. And by row reduction, you get the remaining two equations, and then again, you look for a negative coefficient in the z row, in the objective equation, and you find -1 here, so you need another pivot. And it turns out that it's this x2, so the last system, the equations looks like this. And that's it. Either you've done it or you haven't. So I'll scan this and I'll put it on normal. If you have done the first tableau, then you get a mark, and if you have done a pivot step, then you get another 2 marks, and if you've finished it all, then you still get only 3. And can you please put it down? Thank you. Now, by kind of exceptionally, because this weekend I was in Switzerland, I brought some Swiss chocolate. So if you get at least 1 mark for solving this, you can also take one of these. And now I have done it, so I'm taking one. If you have not done anything, then don't take one, please. If you're only observing, you can also take one. If we run out, I've got another bag, but I don't think we're going to run out, as I know your participation on the homework exercises is not that strong. Okay. Any questions about this problem? No. There will be a lot left. All right. So the plan for the rest of today is we started the simplex method doing them in equations like we've just seen, and we haven't quite finished solving the chess set problem, which is our favorite example problem. So the chess set problem is given in by these constraints, and okay, what we were doing was again, this is revision. So what we did was we introduced new slack variables. Remember, there's 1 slack variable for each constraint. So this is from last week. And then we said that solving this with the slack variables and equalities is the same as solving without slack variables with inequalities. Okay? Now, the next thing we did, we decided that if there's something negative in the objective row, sorry, in the objective equation, in the z equation, that means that this variable x1 is non-basic, okay? And by making it basic, it could get a non-zero positive value. And if it gets a positive value, then that's going to improve the value of the objective, which currently is 0. Because all these, remember, these are the basic variables, right? These are the non-basic variables. They're all 0 in our basic feasible solution. And so the objective is currently 0. So if we do row reduction to this system, so which variables are in the bases in this tableau? X1, S2, and S3, yes. So X1 corresponds to the first equation because it's there with coefficient 1, and it doesn't occur in any of the other equations. And S2, S3 in the next 2 equations. Okay. And like this, we got a basic feasible solution. So what's the basic feasible solution associated with this system, with this tableau, or with this basis? Anybody still remember that from last week? This is where we ended and ran out of time. And okay, so now Z is 800, and X1 is 160 divided by 3. What is X2? What's X2 in this basic feasible solution? Okay, is X2 in the basis? No, so its value is 0. X3? Is X3 in the basis? So its value is? Yeah. And then we've got S1. Is S1 in the basis? No. S2, is S2 in the basis? Yes. Now, it was your implicit homework to work out what 200 take away 160 thirds is. I think it's 440 divided by 3. And S3 is I think 13 thirds. Can anybody check that I'm doing the arithmetic right? Okay, so this is the new basic feasible solution. Is this an optimal solution? Any objections? Sorry, it's a feasible solution, but we don't know whether it's optimal. Yeah. Well, I know. And I didn't quite tell you, because we ran out of time, how you can tell whether it's optimal or not. Okay, and the way you can tell whether it's optimal is you look at the Z equation. Okay, so in the Z equation you always have one Z, and then you have some coefficients times some of the non-basic variables, and then you have the right-hand side, which is the value of the objective in that particular basic feasible solution. And the way you can tell whether it's optimal is you look for the signs of these coefficients. And if you see something negative, like here, -10, then it's not optimal. And if everything you see is non-negative, so zeros, which are not there, or 5, which is positive, then that's it. So in this case, this is still not optimal. Go away. So this basic feasible solution is not optimal because X2 has a negative coefficient which is -10. Why do I write -13 when I say -10? In the Z equation. So whenever you see a tableau which is not optimal, like this one, what you want to do is another pivot step. Now, how did we find out what we do in a pivot step like this? We need to identify what's called a pivot element, right? And so that will be the one element where you will have, which will tell you which variable enters the basis and which variable leaves the basis. Okay, so the entering variable is one of those variables with a negative coefficient in the zero. So there's only one. Okay. So this means that X2 enters the basis. Now remind me, how did we find out which of the basic variables we've got 3 here, x1, s2, s3. Which one leaves? How did we do that?
By rearranging one of the equations, so x2 is constrained, so x2 is less than value or greater, well, always less than value. Constrained.
Yeah, that's correct. So we, from the tableau that we had last week, we did this kind of trick. Now, okay, so I'm going to show you everything. That's long. Okay, so we've got that was our first tableau, right? And there we decided that x1, well, x1 has a negative coefficient there, so it's a good candidate for entering the basis. And now, when we were looking for the variable to leave the basis, we had 3 options: s1, s2, s3. The way we decided it was we said, okay, so s1 has to remain non-negative. And if we express s1 from the first equation, we get 160 minus 3x1 minus 2x2. Now, x2 remains non-basic, it's actually. So x2 remains 0 in the next solution. So x2 disappears. And we have this inequality which tells us that s1, the condition that s1 enforces on x1 is that x1 cannot be larger than 160 thirds. Does that make sense? Yes, it does to me. And the condition that s2 enforces is x1. So if x1 is less than or equal to 200. Okay, so how did we get 160 thirds? Well, we look at the 3 here, and this 160 there. And 160 thirds is this 160 divided by 3. That right? Yes, it is right. Now this 200 is this 200 divided by this 1, which is not and here we did 31 divided by 1/2, so we got 62, which doesn't show, but it is there. Fact. So what we did was divided the right-hand side by the coefficients in the same equation of the variable that's entering the basis, and we got 160 thirds, 262, and then we picked the smallest one, and the smallest one is 160 thirds. Okay? So we're going to do the same thing here. To find the variable which leaves the basis, we need to work out the ratios. Which ratios? Okay, 160 thirds divided by 2/3. Why? Where have I got the numbers from?
First equation.
Yeah, first equation, the right-hand side is 160 thirds, and the coefficient of the variable that's entering is 2/3. So we get 80. And the next one is 440 thirds divided by, oh dear, 10 thirds, is that correct?
Yeah.
you have to keep an eye on my arithmetic because I'm going to make mistakes, I'm fairly sure. What do we get here? $44. And the last one is 13/3 divided by what? Something like, oh, 1/6. And that is 26. Okay. So which one shall we pick? 26, because it's the least one. Which means that S3, because 26 comes from the S3 equation over here, so S3 is going to leave the bases, and so this is where we do the pivot. Okay, now, where's my, oh. Okay, so we've got the pivot, so I'm going to make it disappear because it just doesn't fit all. So I'll cover it. Apologies for that. And the new system has to have, okay, so there's going to be 1, 2, 3, and the Z equations. So it's, okay, so the one that is sort of easy is this one, because we only need to get a coefficient of 1 at x2, and it's currently 1/6. So we just multiply this whole equation by 6. Okay, and what we get is x2 minus s1 plus 6 s3 equals what? I can't remember what it was. Was it 13/3? Oh, it's the. Oh yeah, of course, it must be the 26 that we've just worked out, isn't it? So yeah, so this is 26. Is that clear? There are no questions, which is making me nervous because that means that everybody is asleep. Or everybody's completely lost. Just doing a row reduction. And the purpose of the row reduction is that I want the coefficient of 1 at x2 in this equation. And I want the coefficient of 0 in the remaining rows, in the remaining equations. Okay, so I'm doing it in a slightly awkward way, of course, because I don't really know what I'm doing. Okay, so now I need to subtract 2/3 of this equation. Okay, so the first one is going to be row 1, take away 2/3 times the new row 3. Okay, this is the new row 3, and it was 6 times the old row 3. Oh, it's got a bit less. Anyway, so yes, when we do the subtraction, we get x1. What's next? Okay, I'm taking away 2/3 of x2, and I had 2/3 of x2, so I get the 0 that I want. Here I get plus s1 because I've had 1/3. I'm adding 2/3 of s1. I get no s2, and I get minus 4 s3. And I should get 160 minus 52 thirds. So that's 108 thirds, which actually is a whole number, isn't that? But 36. Okay. So this is 10 thirds. So I need to take away 10 thirds times the new row 3 from the second row, second equation. So what I'm getting is no x1, because there was none and I'm taking away none. No x2, because there was 10 thirds and I'm taking away 10 thirds. I'm adding 10 thirds, so I'll have 3s1. And I'll have s2. What do I get there? There was no s3. I'm taking away 20, so I'll have minus 20 s3. The whole problem is that what I had prepared was doing the different pivot step. And now, last week, you made me do the 100 minus 15. And now I have to do it in my head. Okay, so what do we get here as the right-hand side? I'm lazy. 60? Does anybody else have 60 as well? I'll go with 60. I need to check it. Okay. This number apparently was 440 divided by 3. And I'm taking away 260 divided by 3, so that's 180 divided by 3, so that's 60. Oh, yeah, good. Okay. No x1, no x2, I know that. So what am I doing here? This is row 4 plus 10 times the new row 3, because I want 0 there. Okay, so 10 times x2 minus 10 times x2. Now we've got minus 10. We get minus 5 s1 there. That's bad news. Why is it bad news? No, do we get? Yeah, we do. And we get plus 60 s3. Yeah, equals 1060. Okay. This is a crucial point. You need to understand this. So, who doesn't understand this pivot step? We know what I just done? You know. Anybody else? Okay, good. There are at least 3 people, and the rest of you, I don't believe you that you don't understand, but let's see how this goes. Pivot step. We need to find the pivot element. The pivot element is the red element in the system of equation.
The way I find it is I look at if there's anything negative in the coefficients in the Z term, in the Z equation. Okay. I find the negative coefficient of -10 here. So x2 is the variable that enters the basis. If I have several negative ones, I can pick any one I want. Typically, I pick one with the largest, most negative, and that largest is an absolute value. So x2 enters the basis. Now, to find which variable leaves the basis, I do the ratios. The ratio is the right-hand side, 163rd, divided by the coefficient of x2. And this right-hand side divided by the coefficient of x2, and this right-hand side divided by the coefficient of x2. Okay, so far so good. Now, when I have all these ratios, I select the one that's the smallest among them. The smallest turned out to be this number divided by that number. So we decided that S3, which is the owner of this equation, leaves the basis. X2 will be in the basis, S3 will be out of the basis. What do we need? So X2 becomes the owner of the last equation. What do we need for the basic variable? Well, we need that its coefficient be 1, yes. So it's 1. And we get that by, well, in this case the coefficient was 1/6. So we multiply the whole equation by 6 and we get the 1. Okay? That's what we did. And the next thing we did was we need to subtract 10/3 of the new equation from the second equation, so we get a 0. We need to subtract 2/3 of the new equation from the first equation, so we get a 0. And we need to add 10 times the new equation to the Z equation, so that we get a 0 here. That's it. Okay, has it improved? You understand all the time, you remember making not just setting.
Okay, that's what we do. Is this optimal now? Why not? Because -5. Aha, so it's not optimal. So we need to do another step. Let's not do it. Let's just find the pivot element, and I'll let you finish it in your own time as an additional homework problem. But which is going to be the pivot element? So which variable is entering the basis? S1? Which variable leaves the basis? YS2. Okay, so we have ratios 36 divided by 1. That's 36. Then we have 60 divided by 3. That's 20. Now we have an interesting phenomenon. We have 26 divided by -1. But that one we don't want. That's all. Okay, 26. Ratio 26 divided by -1. Not interesting. Okay, think about why not. So which is the least of the two ratios? 20. So indeed, it's S2 that enters the leaves the basis. Sorry. So this is the pivot element. I hope. S2 leaves the basis. So now you know what to do. So do it, and we'll come back to it next week. However, now we'll do something else. Can you please pass that on? But, so what we're going to do as the next thing is we're going to do something that is more useful. Well, more useful. This is more useful, but we're going to do something that is simpler to write than what we've been doing so far. Namely, we won't be writing a system of equations all the time, because we don't want to do that. We don't want to keep writing x1, x2, s1, s1 all the time. Instead, what we'll be doing is just writing the coefficients. So we'll just be writing the numbers in the system. You can think of it as matrices. Are you doing matrices with Stephen? Yeah. And you solve systems of simultaneous equations using matrices now. Okay, so the same thing is going to happen here. Okay, so now I'll take a risky move. So this is okay. So this problem is the same as we maximize 15, 20. Is that a vector? A row vector? Yeah? And if we multiply it by x1, x2, what do we get? 15x1 plus 20x2. Hopefully you know that much from Steve's lectures. And so what are the constraints? The constraints are, okay, I can just write the numbers, 3, 2, 1, 4. Okay, multiply the matrix by x1, x2. And this should be less than or equal to 160 and 200, like this. Okay, so the first row gives you 3x1 plus 2x2 is less than or equal to 160, and the second row gives you 1x1 plus 4x2 is less than or equal to 200. Are you still with me? Okay, so this is simple. And then, of course, we need x1, x2 is greater than or equal to 0. Now, after adding the slack variables, what we have is 3, 2, 1, 0, and 1, 4, 0, 1 times x1, x2, s1, s2 is equal to 160, 200.
Is that half x1 and half x2 not being included for a reason?
Oh no, it's included for a reason that I forgot to include it. Yeah, thanks. Well spotted. Thank you. Sorry about that. So, what do we get? 1/2. 1/2. This completely messes up everything. 31. Yeah, thanks for pointing that out. Okay. Oh dear. What am I going to do? Okay, so what's this? 1/2 1/2, 0, 0, 1. I do need an S3 there. So the whole time I was thinking that nobody's paying attention, and now it turns out that when I start making mistakes, you actually see them. So that's reassuring. Okay. Correct now? George, you're the chief spotter of mistakes, but yeah. Okay. Okay. In fact, with the objective, we would have 3, 2, 1, 0, 0. Now I hope I'm not going to mess it up again. 1, 4, 0, 1, 0. 1/2, 1/2, 0, 0, 1. Now, where do I put the Z? Okay, I'll put it at the bottom for no good reason. And then we had -15, -20, 0, 0, 0. So that's one matrix. Now, this is a long vector. Z, x1, x2, s1, s2, s3. And the right-hand sides are 160, 200, 31, and 0. Okay? Now we get exactly the same system of equations that we got in the first simplex tableau that we had. Look at this. So look at the system of equations that's here. It's just written as a matrix thing there. Okay? And now, because I don't like writing all these Z, X1, X2, S1, S2, S3, what I'm going to do is I'm going to write them all into a table. And that's the table you have on the other side of this of that sheet. Okay, now for some reason, for historic reasons, I always write the right-hand side as the first column, which is called val in this. Hope that's not very confusing. So this is where the right-hand sides are sitting, the values on the right-hand side, like this. Okay, and the rest of the tableau, okay. Now, to save some writing in space, this Z column, the first column here, is always going to be the same when we pivot, because we don't want to take Z out of the basis. Okay, so I won't write it at all into the tableau. So what I'm going to write into the table here is just the coefficients from the matrix that was above. Okay. Oh no, that's not true. Just the coefficients from these 5 columns, not the Z column. Okay. So the first column is 3, 1, 1/2 minus 15, 2, 4, 1/2 minus 20, 1, 0, 0, 0. Like this. And then, so I wouldn't forget which variables are in the basis and which correspond to each of the rows or each of the equations, I'll just write them here. S1, S2, S3. And this is how I get the first tableau in the form of a table which corresponds to matrices which correspond to a system of linear equations. Okay, so you see these things are there. A table like this, matrices and vectors like that, system of simultaneous equations like the one we had. And each of these things is really the same thing. It's just written in a different way. So from now on, we will stick to this table notation. But somewhere at the back of your mind, you should always think of this being really corresponding to a system of simultaneous linear equations. Okay? Good. It's the same as always. I never manage to do everything that I want to. However, even so, let's have a look. So we've written the first table as the first tableau. And now, what does the simplex method do with these tables? It kind of works like this. So you look at the table, and the basic feasible solution corresponding to this one is S1 is 160, S2 is 200, S3 is 31, Z is 0, and the non-basic variables are 0 as well. So that's X1 and X2. Now, is this optimal? No, it's not optimal. Why is it not optimal? Because there are negative entries in the Z row. Okay? There are no negative entries in the Z row, the tableau is optimal. So we've got two negative ones. Unfortunately, you picked the minus 15. You can see in the book that if you pick the minus 20, it's faster. But you've said minus 15, okay, so I'll do the minus 15. So this negative number in the Z row tells us which variable, one of them, enters the basis. Now, we need ratios. Okay, so ratios are 160 from here, divided by 3 from here, 200 from here, divided by 1 from here, and 31 from here, divided by 1/2 from here. And we know from before that this is the least ratio. So this element over here is going to be the pivot element. Okay, I'll quickly finish this. Oh, no, I won't. This is bad. Okay, it's not so bad, but because we're not running out of time. We have 2 hours next week, so we can do all the pivoting in the world. Yeah, have a look at the homework. Maybe you can solve it, maybe not. If you can't solve it, we'll leave it for in 2 weeks' time. And I'll see you in the labs or on Friday.